Hey, Plumber Tom here. If you're studying from the Mathematics for Plumbers and Pipefitters book, you've come to the right place. I'm glad to help you with your understanding. Don't forget to check in the description below this video for access to books and resources that will help you with your understanding. There are online courses and other things that you can take that will help you prepare for a state test. When you purchase from those links, you're helping me to be able to create more great content. Thanks for watching. Hello, welcome to this presentation of Mathematics for Plumbers and Pipefitters, Unit 33. My name is Thomas, and in this unit, we will look at elevation and grade. Let's get started. The text here in Unit 33 has several important terms that you need to understand, starting with elevation. It says, an elevation is a certain distance above or below a fixed point. And we use this as a vertical reference above a fixed point. Now, elevation is used to describe the difference in height from that fixed point. The easiest and most obvious elevation that we use all the time is in land or geography, and that is sea level. Sea level is pretty steady throughout the planet, and from there we can go up or down, and that's how we measure the elevation of the land or the geography. There are some elevations on this planet that are actually below sea level. The Netherlands has many areas that are below sea level. The Dead Sea over in Israel is also below sea level. But most elevations are going to be above sea level. Now in Utah, I don't know, average elevation is probably 4,500 feet above sea level. And different locations vary above or below that too. But the point here is that we have elevation as a fixed point, and that's a reference from which we can measure. An architect may specify building elevations based on sea level. Sometimes our plans will actually have the literal elevation above sea level marked, especially on a plot plan that would show the topography of the land. But that's not always real easy to measure from or calculate from up or down. And so on most buildings, engineers will put a fixed point and they will refer to it as 100.00. And this is used as a benchmark. The text here points out that a benchmark is some non-moving point, as on a curve. Now they use 100.00 because it is an easy number to add to or subtract from. So we have that starting point, and it's easy to refer to. So for example, they give the first floor elevation for a building may be 103.50 feet, which would mean that the finished floor level there, first floor, is going to be 3.5 feet higher than the benchmark. And the benchmark, again, is going to be some point there on that property, and we're going to call it 100.00. Now the basement is going to be below that. And in this case, they say elevation 94.00 would indicate that we are 6 feet below that benchmark or that fixed point. This gives us a way to indicate on a plan how deep something is or how high above the ground something is based on the references of that specific building. Now, why do we even get into this? Why don't we just use inches and feet like we always do out in the field? Because that's what plumbers use. Well, that's because surveyors and civil engineers, the people who design these buildings and draw them up, they use elevation measurements based on feet and decimal parts of a foot, like what we're seeing there with our benchmarks. 103.50 feet. That gives us nothing on inches, nothing on fractions of an inch, but it's the way that they measure on a plan. Now they'll measure down to the 100th, so all the way to 0.01, and that's the smallest elevation difference that they're going to indicate on a plan. But again, all of that is in decimal feet. What do we use? Well, again, when we're out there in the field, we're using our measuring tapes with feet, inches, and fractions of an inch. So there's a difference here on the way that these measurements are being described. From the engineers and the plan to those of us who are actually installing, and we have to be able to convert that. We did that back in Unit 6 of this book, and I've referred you back to that in the previous unit. But those are important skills for us to have to be able to convert measurements back and forth, because on a plan, sometimes it may be in decimal feet, and we have to be smart enough to know how to handle that and use it so that we can actually install with our measuring tape. So because we're using that as our measurements, we're going to convert to the nearest eighth of an inch. And I demonstrated in Unit 32 how an eighth of an inch is very close to 1/100th of a measurement, or of a foot, right? So if we have a foot and we cut it into 100 pieces, that's very close to a foot that's cut into eighths of an inch, because as you recall, there are 96/8ths of an inch in a foot. That's pretty close to 100. And so we just refer to it that way, right? Anyway, when we're converting, we're going to move over into our measurements, feet, inches, and fractions of an inch, to within an eighth of an inch. Now, elevation and those changes in elevation all become very important to us as plumbers, because as we measure a pipe, follow the center line along through into the building, drainage pipes are going to be required to have some slope. And that's going to be changing. So the elevation is changing as it goes. And at certain points, we can and should be able to measure and identify what is the elevation here, and it's moved. What is the elevation there? How is that changing? And we've talked about slope and how to calculate that. In this case, we're using elevation to describe those different points along a sloped pipe. And we'll be using this both in this unit as well as in the units going forward, because we'll be following pipe through on a plan and marking those elevations so that we can accurately describe how these pipes should be installed. I want to take a quick time out here and invite you to get your math book out and have it open, have it with you. I know you're busy. I know sometimes you listen to these presentation videos on the fly, but to understand this math, you need to be following along. You need to look at what's in the book. And some parts of this, I'm going to pull away from the book and be showing you, running calculations, but you need to see your book. So whenever we're doing this, make sure you're following along with me in your book. That will really help your understanding. Take a minute now, grab your book, and let's get started. Let's have a look at some of the sample problems. You'll be calculating the same sort of thing on your exercises, so let's go through a couple of these. Sample problem 1. It says convert 8 feet, 4 5/8 of an inch into engineer measure. So this is kind of a review. We're going to take that field measurement that we would use with our measuring tape and convert it over into the engineer's measure, which is feet and decimal parts of a foot. Now, when it comes to the feet themselves, they don't change, right? There's 8 feet here in the builder's measurements, and there's going to be 8 feet in the decimal engineer measurements. But it's that 4 inches and 5/8 of an inch that we need to convert over. And this is how we're going to go about that. If I take 4 5/8, I need to convert that first of all into a decimal form. It's still going to be in inches, but I just need to get that fraction over into a decimal. Well, how do you turn a fraction into a decimal? A fraction is a division problem. You have 5 over 8 on the fraction, or 5 divided by 8. If I take 5 and divide that by 8, I'm going to get 0.625. I'm going to keep that with my 4 inches. I've got 4 whole inches plus 0.625. I'm going to have that 4.625 as my decimal inches. Now remember, we're trying to get to decimal feet. So I'm still going to do a little bit more on this conversion to get it over to feet. But at least now I'm into the decimal form, and that's easy to play with in a calculator, right? Which, by the way, that's exactly why engineers use their measurements in feet and decimal parts of a foot. It's easy to punch into a calculator. So let's convert that 4.625 inches into decimal feet. And if you remember, when we're going to convert inches into feet, we divide by 12. So 4.625 divided by 12 inches in a foot equals 0.38 decimal feet. So now we've converted that same measurement, which is 4 5/8, into a decimal inch measurement, and then into a decimal foot, which is 0.38. Now we had that whole number of 8 feet, and we can just put that together with our 0.38 decimal feet, and our total then is going to be 8.38 decimal feet. Now we've converted our builder's measure into engineer's measure. Now, in the bottom part of this sample problem, they give another way to go about this. It gets us to the same answer. So if you want to do it this way, you can. I think the way that we demonstrated first is probably the most logical. But let's just run through this real quick. It says, here's an option. You take your 8 feet just like we did before. Save those aside because they're whole feet. And then you break apart the inches and the fractions of an inch. So they say, well, we've got 4 inches. We'll divide that by 12 to get 0.33. And that's going to be our decimal feet, right? But then we take that little fraction of an inch. If we've got 5/8 of an inch, and remember that each 1/8 of an inch is equal to 1% of a foot, or 0.01. I mean, we're close enough with the eighths, right? So they just say, well, let's just take 0.01 for every 1/8 of an inch, and that's going to get us into a decimal form. So we have 5/8. So we're going to times 0.01 by 5 and get 0.05. And then we just have to add all those together. So that would mean 8 foot 4 5/8 equals 8 feet plus the inches portion converted into decimal feet, 0.33, plus the fraction of an inch portion converted into a decimal form using that simple percentage is 0.01. And when that's 0.05, and we have a total of 8.38. You see, we get the same number, 8.38 decimal feet, whether we do it the one way or the other. And you can decide, like, how do you like to think about this, right? In this second option, you kind of break it up into more pieces and convert it over. In the end, we come up with the same answer. All right, let's do another sample problem. This is number 2, and this time we're going to be converting from the engineer measure, and we're going to move that over into builder's measure so that we can use that with our measuring tape. The number they give us here is 94.28 feet. That's all in decimal feet. Let's convert that over. Anytime we do this, we're going to hold our whole feet, right? So we know it's 94 feet. We're just going to set that aside and say, okay, we got our 94. What we need to convert is the 0.28 decimal feet. What is that in inches? Well, let's find out. First of all, let's convert it over into inches, right? We can take that 0.28. Anytime we're going from feet into inches, we multiply by 12. So 0.28 times 12 equals 3.36 inches. Now we've converted over into inches. But that still leaves us a decimal. We need some fraction here. We know we have 3 whole inches, but what is 0.36 in fractions of an inch? If we want to convert 0.36 over to fractions of an inch in eighths of an inch, let's just multiply by 8 over 8. So 0.36 over 1 times 8 over 8. All right, follow me here. We have 3.36 inches. We're just looking for this portion, trying to convert that into fractions of an inch, right? So if I've got 0.36 inches, I can put that over 1 because I need to convert this into a fraction and multiply that by 1 over 1. That doesn't change anything, right? But if you'll remember, we can cut that into pieces. So that would give us 8 over 8 and the opportunity to convert this into a fraction, right? So then I'm just going to multiply straight across. That's how fraction multiplication goes. You multiply the numerator that's on top straight across. You multiply the denominator on the bottom straight across. It's going to give us a number over 8. Let's see what that ends up being. Bring in the calculator here. If we do 0.36 times 8, it's going to give us 2.88. And once we come to this point, we've worked that through, it's time to just round up or down. We're done with decimals. So 0.88 is pretty close to 3/8. And that's what we're going to be using here is 3/8 of an inch. Or combine that back together, we have 3 and 3/8 of an inch all together. That's our total. So if we come back over here, we converted our 0.28 decimal feet into 3.36 inches. And now we've converted that 3.36 inches into 3 3/8 inches. And at that point, we just put it back together, right? And we end up with 94.28 decimal feet is the same as 94 feet and 3 3/8 inches. Now we can use our measuring tape to get this right. Okay, they give us another method at the bottom. We see this also. And the purpose for this is like, what's the fastest way to come up with this? It took us a minute to go and convert decimals to fractions and to figure that all out. What if there's a slightly faster way? Well, they say, if we consider that 1/8 of an inch is equal to 1% or 1/100th of a foot, why don't we just say, well, however many hundredths of a feet there are, let's go over 8 and see what we come up with, right? So on this one, we take our 94. We know we've got a solid 94 feet. Then we go 0.28 feet, and we're going to divide by 8 inches. That's going to tell us how many inches, or basically converting that decimal foot over into inches, is going to give us 3.5 or 3.5 inches. And then we just tack that on, right? So we got 94.28 feet equals 94 feet and 3.5 inches. Now, you and I can see that there's a difference here. What we calculated before was 94 foot 3 3/8 of an inch. Here, we're coming up with 94 foot 3.5 inches, or, that's 4/8 of an inch, right? Our difference between those two is 1/8 of an inch different. When it comes to actually measuring out there, does it really matter 1/8 of an inch? Do we really care that much about 1/8 of an inch? Maybe not. In which case, if it's faster to do this, just take your decimal parts of a foot, divide it by 8, and then convert that into your fractions of an inch. Maybe that's faster. Is it as accurate? Probably not, because we're missing that little bit of a difference that happens because 1/8 of an inch is not exactly 1%. It's 1.04%, as we learned last unit. So anyway, there's 2 options for you here. We'll accept either answer when it comes to, exercises here in the book, but there's a couple options for you. Let's go on to sample problem number 3. And they give us several pieces of information, and they're going to ask us questions, and we're going to calculate from this, okay? Now, I'm going to invite you to keep looking at your book. I'm going to pull up my pad, and we're going to draw this out and look at it together. I want to make sure you understand what's happening here. Okay, follow me here. We're dealing with a building, so I'm going to draw a portion of this building out for us over here. This is a foundation wall. We have a footing down below that, and we have a foundation floor. This is going to create our basement. Now, on top of that, if we're just looking, this is a side elevation view of the plan. We have the floor, so you got floor joists sitting on top of a foundation wall. And then the wall goes up onto that first floor. This is going to be a frame wall, right? Coming up their ways. And we'll have some trusses that form the roof. So here's our building. And we're going to have some measurements in reference to this. What they give us as a benchmark is 100. But 100 sounds to me like it's out here. This is our finished grade, 100. Maybe there's a point that we have marked out there. 100 is not equal to the finished floor. That's up here. 100 is way above our basement floor, which is clear down here. But what we're going to be doing is calculating the difference and showing some of these measurements. So information that is given to us is that we have a benchmark, which is 100. We have a basement floor, which is 94.7 feet. So they tell us that on our plan, 94.70. And we have a first floor, which is 102.95 feet. These are the measurements that are given to us in the sample problem. And then we're asked a series of questions. The first question is A. How far below the benchmark is the basement floor? So we can calculate that, right? If benchmark is 100.00, and we're trying to figure out where the basement floor is, we're going to subtract the difference, which is 94.70 feet. And that is going to give us 5.30 feet. So we're here in decimal feet, right? Now, they'd like us to convert this over into our builder's measure, because you and I might need to be able to measure down and find where that's at. So if we convert that 5.30 feet into builder's measure, we take our 5 feet. We're going to save that. Then we take our 0.30 decimal feet, and we want to get that over in inches. So we multiply by 12, and that's going to give us our inches. Let's put our calculator into this. 0.3 times 12 equals 3.6 inches. Now we're into decimal inches. If I want to convert that over, I'll save my 3 inches, right? I've got my 3 solid inches. But then I've got 0.60 of my fractions of an inch. Let's multiply that by 8 over 8. So that's going to be 0.6 times 8. That's going to give me 4.8, or pretty close to 5 over 8. I'm going to combine these pieces, right? I knew I had 5 feet, 3 inches, and 5/8 of an inch, so it should be 5 foot 3 and 5/8 of an inch. That is my difference from finished elevation at 100 down to the basement level. Now, if you look closely in your book, there's kind of a discrepancy there. As they convert, they have 5 foot 3 and 3/8 inches, but then when they break it all out and do their little measurements showing conversions, they end up with 5/8 of an inch. I think we did a pretty accurate job here. I mean, look at our math. Prove me wrong. You might have to do that occasionally in this book. I'd like to say that all the answers in this book are like the way they should be, but you and I have been in this book for a while and know that sometimes they make mistakes. I really should write that to the editor. Maybe start thinking about that. Let's go to the next one, which is B says how far above the benchmark is the first floor. In this case, we're going to start with our finished floor elevation, 102.95 feet. And we're going to subtract our benchmark. So we want to know how far above that we are. Pretty basic math, right? Just take off the 100 and we're going to end up with 2.95 feet. Now we know, right? But let's convert that over into our builder measures so we can use our measuring tape. We're going to keep our 2 feet, but we've got 0.95 feet. Let's times that by 12. We'll convert this over into inches. 12 times 0.95. That gives us 11.4. We're converting this over into inches, so that gives us 11.4 inches. Then we can save that 11 inches, right? And maybe we convert this last fraction of an inch. We got 0.4 times 8 over 8. 0.4 times 8. It's going to give us 3.2. Let's just round up. We'll call it 3/8 of an inch. Combine those together, we're going to have 2 feet from here. We had 11 inches. And we had 3/8 of an inch, so 2 foot 11 and 3/8 of an inch. That is the difference from our elevation, benchmark elevation, to the first floor. Now we have something we can measure with. All right, for part C, it asks us how far is the first floor from the basement floor. In this one, we're not even going to use our reference benchmark 100. We're just looking at the difference between these two. So if I take 102.95 decimal feet and subtract 94.70 decimal feet, that's going to be the difference between these two, right? Let's give that a try here. We've got 102.95, and we're going to subtract 94.7. That gives us 8.25 feet. Now let's convert that over. We're going to keep our 8 feet. We want to be able to use our measuring tape. So I've got 0.25 feet. I'm going to times that by 12. This one we're not going to have much on fractions of an inch, right? 0.25 times 12 is 3. And that's going to give us inches. So our difference between the finished main floor and the basement is going to be 8 feet, 3 inches. That one was not too complex on our conversion to fractions of an inch. That completes A, B, and C for sample problem 3. You're going to be doing something similar on your exercises, so if you need to refer back to this, it'll take you step by step on how you calculate these. Okay, we have one more sample problem here. It says on number 4, a house drain has a run of 30 feet at a grade of 1/8 inch per foot. The low end has an elevation of 93.50 feet. What is the elevation at the high end? We want to be able to describe the depth below our fixed point, our benchmark, as to where the pipe should be here and where the pipe should be there. Now, I'm going to point out that it is often helpful to draw a picture like you saw me do in the last sample problem. I'm going to draw this out to help us with understanding, but you should try that yourself. If you're struggling with understanding here, maybe just sketch it out for a minute and see if that helps you. All right, yeah, let's just try and sketch this out. It mentions a house, so we'll put a house in here. And this house is going to have a building drain coming out from underneath, right? And it's going to slope out. Now, the information that they gave us was that the drain from the house runs 30 feet. So maybe there's a tie-in to the public sewer. And the distance that we have from the house is 30 feet. And they also tell us that this pipe is sloped at 1/8 inch per foot. So that's going to be our grade. The other information that is given is that we have a depth here. This is an invert elevation or below 100. So say our benchmark 100 is up here somewhere. And we're going to come down below that. We end at, on the low end, 93.50 feet. What they want to know is on the high end, say here at 30 feet, what is our elevation? And we can calculate that difference by taking the distance that it has traveled, which is 30 feet, and multiplying that by 1/8 inch per foot, right? That's going to give us in inches the difference from the upper end to the lower end as this pipe slopes. I'll remind you, when you multiply this, you can multiply by the decimal form. So if I take 1 divided by 8, that's going to be 0.125. That's the same as 1/8 of an inch, right? 125. So I can multiply 30 by 0.125, or I could also divide it by 8 as we're coming across there, and it's going to be the same thing, right? So I've got 0.125 times 30. This is going to give me my inches, but we're already in decimal form. I've got 3.75 inches. Now I need to get that over into decimal feet so I can add it to my 93.5, and that'll give me like what's different here, right? So to convert that into decimal feet, I take my 3.75 inches. Then I'm going to divide that by 12 to convert that over into feet. So 3.75 divided by 12 is going to give me 0.3125 decimal feet. And we can round that, or more or less, it's small enough. Let's just use our 0.31, and we'll add that to what we have. We're given on the low end that we have 93.50 feet. Then as it slopes up over to here, we know our difference now. In decimal feet, it's 0.31 feet. So we can add those together. If I take 93.5 plus 0.31, it gives me 93.81 feet. That's up here, right? 93.81 feet. That's my elevation. If I'm speaking with an engineer, I can give him a measurement that is in decimal feet or engineer measure, and they're going to understand the difference or what's going on here. So if you look at this section, they take the 30 times 1/8 of an inch and they get 3.75. They convert that right into fractions of an inch, 3 3/4 inches. And then they're converting that engineer measurement, 93.50 feet, into builder, which is 93 foot 6 inches. They add that together and get 93 feet, 9 3/4 inches. So they've come to that in builder's measure. We came to that through, our engineer measurement in decimal feet. It's all the same measurements, right? Now look at this second part. Looking back over here at sample problem 4 in the book, kind of following through what we did. We sketched it out, we calculated. There is one difference here, and that is that, once again, they're using the 1/8 inch is about the same as 0.01 foot at the bottom here. So it says, therefore, 0.01 times 30 would be 0.30 feet as a difference in elevation. And then they're just adding that 0.3 or 0.30 to their starting elevation. They get 93.80 feet. Now, if you compare that to what we got 93.81 feet. It's within 1/100th of a decimal foot. I mean, our answers are really close. And so, yeah, good enough. Now, was that faster? It's probably faster. If you look at that, just say, well, how many 1/8 of an inch does that equal? We got 30/8 of an inch. And flip that into decimal feet. Add that to our measurement. You might do that going forward on some of your assignments. They give these different options, but there is a slight difference in the outcome. All right, this concludes our discussion of Unit 33, Elevation and Grade. You do have a series of exercises to do. These follow the sample problems that we've just done. So if you run into problems or questions, you can watch the video again. You're going to convert measurements, and then you're going to play with benchmark and elevation differences, Good luck with your exercises, and I will see you in the next unit.